Welcome back to Tech Pulse, your go-to show where we break down the latest breakthroughs in science and technology, making them not just digestible, but actually exciting. I'm Zaper.
And I'm Puck, your slightly overcaffeinated, always curious co-pilot, asking the, wait, but what does that really mean questions, so you don't have to.
Quick reminder before we dive in, make sure to hit subscribe, leave us a review, and share this episode with a friend who loves a good cosmic mystery. Today's headline is a big one. Scientists crack mystery of sun's magnetic field engine.
Okay, pause. That headline sounds like a sci-fi movie trailer. Coming soon, the magnetic field engine. But seriously, what exactly does that mean?
Great question. Let's unpack it. The magnetic field engine refers to a hidden layer inside the sun called a tachocline.
Tachocline? That sounds like a race car part. Like, I just upgraded my Tachocline for better horsepower.
Not quite. The tachocline is a super thin boundary layer deep inside the sun. Imagine it as the dividing line between two very different zones, the sun's calm and stable inner core and its chaotic, swirling outer layers.
So it's like the border checkpoint inside the sun. One side is orderly citizens, the other is a mosh pit.
Exactly. And this boundary is where the sun's magnetic fields are generated and controlled. Those magnetic fields are what eventually cause solar storms, flares, and all the chaotic stuff that can mess with our satellites, power grids, and even your GPS.
Okay, now I get why cracking this mystery matters. If we understand that layer, we can get better at predicting space weather.
Right. So here's what happened. A team at the University of California, Santa Cruz, using NASA's most powerful supercomputers, created the first fully self-consistent models of the sun's tachocline.
Self-consistent, meaning the model actually explains itself instead of being forced.
Exactly. In fact, the most exciting part is that their model spontaneously created a tachocline without being programmed to do so.
Wait, so it's like they set up the right physics, pressed run, and the sun's hidden engine basically appeared naturally?
Yes, that's how scientists know they finally captured the real physics at play.
All right, tell me how much power it takes to simulate the heart of the sun.
Get this. They use NASA's Pleiades supercomputer for tens of millions of computational hours. It took about 15 months of non-stop calculations.
15 months straight? That's like binge watching every season of every show on Netflix twice and still not being done.
Pretty much. These were what the researchers called hero calculations. They're so big and complex that only a handful of teams worldwide could even attempt them.
Okay, bring this back to Earth. Why should I, or anyone listening, care about some ultra-thin solar layer?
Because the tachocline is directly tied to the sun's magnetic activity. That activity drives solar storms, the burst of energy that can fry satellites, disrupt communications, and even knock out power grids.
Right, like those geomagnetic storm erupts we keep hearing about.
Exactly. In fact, NOAA issued multiple warnings just earlier this month for G2 and G3 level storms. That's moderate to strong. Strong enough to mess with navigation systems, internet connectivity, and even cause blackouts in extreme cases.
So knowing how the sun ticks isn't just science for science sake. It's about protecting our tech infrastructure.
And here's where it gets even cooler. NASA is also working on using artificial intelligence to forecast solar storms. Their current models can predict disruptions about 24 hours in advance.
That's not bad. Like getting a weather forecast that says, tomorrow, pack an umbrella, and also maybe unplug your satellites.
Yes, but if we can understand the tachocline better, we might push that forecast window even further, days in advance, maybe more.
Hang on, I remember you said there's some kind of two-way relationship going on.
Yes, that's the mind-bending part. Researchers think that tachocline helps create the sun's magnetic fields, but also the magnetic fields might help create the tachocline itself.
Whoa, so it's like, which came first, the chicken or the egg, but on a star-sized scale?
Exactly. And cracking that puzzle could reshape how we understand not just the sun, but stars in general.
Okay, let's zoom out. Why does this matter for other stars?
Because the sun is just one star among billions. If we understand how its magnetic field works, we can apply that knowledge to other stars. That helps us predict which stars might have stable environments, maybe even ones that could host habitable planets.
So in a weird way, studying this thin invisible layer inside the sun might one day help us find Earth 2.0.
Exactly.
All right, so let me see if I've got this straight. After decades of head-scratching, scientists finally cracked how the sun's Tachocline, the boundary between calm and chaos, actually works. They did it using a monster NASA supercomputer, millions of hours of calculations, and a bit of patience.
And the result? Better understanding of solar storms, more accurate space weather forecast, and new insights into how stars create magnetic fields.
Which in plain English means fewer surprises that fry your Wi-Fi, and maybe a roadmap to discovering habitable planets.
Nicely put. And that's a wrap on today's episode of Tech Pulse. If you enjoyed this breakdown, don't forget to hit like, drop us a comment, and subscribe so you never miss a peek into the future of science and tech.
I'm Puck.
And I'm Zaper. Thanks for tuning in. See you next time on Tech Pulse.